Okay, let's come back to part 2 for thermochemistry. If you find it difficult in the following explanation, you may go back to look at part 1 first. And now I have to let me just have a look of what we have done in part 1. You look at number 1, we revised the equation E equal to mc delta T. M is the mass, C is the specific capacity. We always treat the solution, aqueous solution, to be water. We assume that the capacity of them are the same as water. Okay, and then delta T is in Kelvin scale, which is also the same as Celsius scale if you are talking about the delta, the difference. And then for number 9, we have talked about in part 1 about this equation. When you have a enthalpy change, a heat change, it always refer to an equation, a given equation, except those who have a specific definition, such as heat of combustion, enthalpy change of combustion, and enthalpy change of formation, enthalpy change of neutralization. Apart from that, you talk about enthalpy change of reaction, you always refer to an equation, and in this equation is called thermochemical equation, and the number of moles there and the heat evolved or heat change may be absorbed. They are all in direct proportional. You use the direct proportion to calculate them. Okay, I remind you we have explained it in part 1. And then also for number 12, which we explained in part 1, I remind you that for all that enthalpy change, you have the heat change given by reacting a certain amount of reactant. It may not be 1 mole. So you calculate the heat evolved, and then you divide by the number of moles present. So here you have you have a 2.75 gram divided by 137.3 gram, which is a molar mass. So you always have to convert the heat amount given out, by the number of moles, so that you convert it to per mole. Okay, energy change per mole. This I remind you in part 1. If you are not familiar with it, then you have to go to part 1. And then also we look at 22 in part 1 already. I remind you that there's a law called His law. His law is a Russian chemist in Sweden. A Russian chemist make a law, say that the enthalpy change of a reaction is independent of the route it takes. Or in another way, it also says that the enthalpy change of a reaction is only affected by the initial state and the final state. There's nothing to do with the intermediate steps. Okay, so we have discussed about this number 22. W become Z is P. Then you can do another way. We go to X by Q, and then go to Y by a change of R, and then from Y to Z you reverse the reaction. You have minus S, so you have P equal to Q plus R minus Z. This is what we have done in part 1. Okay, and now we have to look at new things. Maybe number 11 here. Okay, number 11, the enthalpy change of the following represent standard heat of formation. So we go to heat of formation is the same as enthalpy change of formation. And enthalpy change of formation, we have definition. You have to memorize these 3 or 4 definition. It always refer to 1 mole of substance formed, okay, from element, and the element should be in their standard state. Standard state means they naturally occur in that state. For example, oxygen will be gas state. Okay, hydrogen will be gas state. Metal usually will be the solid state except mercury. Okay, now we have calcium sulfate solid. So we come from copper element, sulfur element, and oxygen element. 2 times 2 is 4, so you have to be balanced. The equation should be balanced, is by definition. And the standard state metal is solid, sulfur is solid, oxygen is gas. So it's a very simple one. So we learned the definition for heat of formation now, and we may come to another one, number 13. Now we come to another definition, standard heat of combustion of methane. So methane is 6,4. You have to burn 1 mole of that substance. You have to say completely, this score 1 mark. If you say in excess oxygen, it will be better. Okay, and then you must be at standard condition. So the methane at standard condition is a gas, and the oxygen under standard condition, which is 25 degrees Celsius, which is 298 K Kelvin scale, 298 K, and 1 atmosphere pressure. So you burn completely. The product would be CO2 gas is the standard state, and then water will be liquid state. Okay, then this is definition. There's nothing difficult. I just wanted to remind you about several definitions: heat of combustion, heat of formation, and then now we go to another one, the heat of neutralization, for number 16. Okay, we go to another common examination point, which is the heat of neutralization. So by definition, heat of neutralization, or the enthalpy change of neutralization, refer to production of formation of 1 mole of water, okay, under standard state. So will be liquid water at 25 degrees Celsius, 1 atmosphere pressure. Okay, and now it is related to the delta H of neutralization. Okay, we want to have the largest delta T. So first of all, the amount of heat is proportional to the number of water. So we just calculate which one has the highest number of moles of water, and you find that A has the least. Okay, 51. The concentration 1 and the volume is 50. So it's smaller than 50 times 2, and the same as 100 times 1. So B, C, and D, they give the same number of moles of water, so they produce the same amount of heat. So we cancel A. A is least, not largest. It's the smallest. And then we compare B with C and D. Now you have totally 50 plus 50 aqueous solution at the end. So you have 100 gram of aqueous solution. But for C and D, you have, for C, 100 times plus 50, for D 100 plus 100. So the smallest volume in B give a higher rise in temperature. Okay, you only have to raise the temperature of a smaller amount of water, so that the temperature rise will be biggest. Okay, so I just want to to remind you that delta H of neutralization is related to the number of moles of water. By definition, heat of neutralization refers to the production of 1 mole of water. Okay, under standard states. Okay, then we come to number 17. 17 is a bit interesting now. So it go to medium difficulty. So you look at this one. Mixing acid and alkali, you have strong acid, strong alkali. 20 is the volume, this is the concentration. You have number of moles is C times V, okay? Concentration times the volume. So remember, C times V, 20 times 1, 25 times 1. And then the second one, the strong acid, but this is a weak alkali, also 20 times 1, 20 times 25 times 1, the same. So the final volume of water or aqueous solution is the same for the first two. For the first two, the same. But for the third one, you have the concentration double, and then the volume the same again. The final volume will be same again. But the amount of water produced will be double because you have 2m, okay, 2 mole per dm cube. Therefore, Z has the highest has the biggest amount of heat evolved, and then the second one will be X. The less the second value, we don't count the negative sign. The amount of heat will be biggest for Z to be given out, and then secondly will be X because it's strong acid, strong alkali, and then the least one will be the middle one, because you have weak alkali. So when you are examined about heat of neutralization, in the question you always have some weak alkali or weak acid appear. You have to know that, understand that some heat will be absorbed for dissociation for weak alkali, okay, and for weak acid, some heat will be absorbed for ionization of weak acid, okay, because weak acid and alkali are only partly dissociated, okay. Now, so for the value concerning the temperature rise, okay, so Z has the highest, and then Y will be the lowest. So Z the highest, Y will be the lowest, okay, because it's weak alkali. You have some heat absorbed to dissociate the ammonia to hydroxide ion, okay. So we deal with just deal with neutralization, okay. Now we go to another one. Okay, let's go to some basic definition. It's a bit difficult, just be patient. It is borderline out of syllabus, or just borderline, okay. I want to talk about number 3 and number 4. It's about internal energy change and enthalpy change, okay. Internal energy change is measured, okay, delta E at constant volume, but for enthalpy change, delta H is measured at constant pressure, which is the normal condition while we are doing experiment in our laboratory. We always open the mouth of the test tube, let it connect to the atmosphere. We don't have a stopper there, and then we measure the heat change. This measurement is about delta H. But on the other way, if we put a stopper there and don't let the stopper open, then we do the experiment, then in this measurement we are measuring the delta E, because the volume we confine it to the container, the vessel. We don't open it, so the gas cannot escape. If the gas escape, it will occupy a bigger volume. It won't be constant volume. Okay. So what's the difference? When you're measuring delta H, if the number of moles of gas of the reactant is not equal to the number of moles of gas in the product, so there will be some difference in the number of moles of gas, means that some gas may escape or some gas may go inside. So let's talk about some gas escape. If there is some gas escape, there will be work done against the atmospheric pressure, because we are under atmospheric pressure, and then the gas evolved will have to push the atmospheric pressure outward, so that some energy is absorbed. Okay, it use up some energy. So in this way, if it is an exothermic reaction, the delta H, you open the vessel, so there are some work done lost. So the value, we don't talk about the negative side, we just talk about the magnitude. The value of delta H will be smaller than the delta E, the value of delta E. Okay. But if you consider about the negative value, then you have the reverse way. Okay. This is a bit on the borderline of the out of syllabus line. Okay. But you, to be good, to be expert, you have to learn it. And now look at B. You have 2 mole of gas on the left and 2 mole of gas on the right. Therefore, no matter how you react, there are no volume change. Okay. So the delta H will be nearly equal to delta E, because no volume change, no work done against the atmospheric pressure. So delta E is roughly equal to delta H. Let's look at number 4 here. And now it's about delta H and delta E again. It's a very common experiment. Magnesium, some metal, magnesium or zinc or any metal above zinc can do. You have hydrogen gas given out, so the delta H is actually is -1 is exothermic, but the hydrogen gas evolve will push the atmospheric pressure, is have to overcome the atmospheric pressure. Some energy is used up. Therefore, the delta H value, the magnitude, we don't consider the minus sign first. We only consider the magnitude, will be smaller value than delta E. Okay, but it is exothermic, so minus a smaller value will be bigger. So if we consider the sign, delta H at standard state will be bigger than the delta E, the change in internal energy in the standard state. So we have A here. So hope you understand this one. So if you don't understand number 3 and 4, it's okay. It's only borderline. You're not going to get a 5 double star. You just get a 5 star. It's okay. It's good enough. Okay. Now we come to some more example. We go to number 23. More exam orientated question. Number 23. Number 23 here. Okay. Oh, it's very similar to exam question. Okay. So you have a lot of equation. It's a bit terrible to some of you. So what relation between enthalpy change PQRS? Okay, we just choose the first one and write it as the main reaction from left to right, and label it P here. Okay, P here. And then we want to find the relationship, so we look for N2, where we look for N2 in the rest of the three equation, we find N2 here. So we find this one. N2, you have 2 nitrogen, so you write 2NO. Okay, 2NO plus you become 2NO here. So N2 and NO, you have this equation. Okay, so you just write this down. It is Q. It's Q. So you have Q here. And then now you have NO. You want to change. You look at the other. You have NO here. Then you just write this NO become NO2. But you have 2 NO. But here you have only 1 NO. So you multiply the R by 2. So you have 2R. Understand? And then for the NO2, how can we go back to N2O5? You look at another equation. It must be there, okay? It must be there, otherwise the question will be wrong. So you have N2O5, 1 mole here. So to look at this one, oh, luckily we have 2 moles of NO2. Then we complete the cycle, and this is S. Then use his law, by his law, okay? Then P going initially to the final state on the right. You can do another way in a cycle, energy cycle. So Q plus 2R, and then S plus S. Straightforward. So starting with a question with 4 terrible equation, you just go slowly, then you get the answer. Okay. So if you get the answer, there's nothing difficult. It's only this 2R. This part is a little bit difficult. You multiply by 2. This one. Then you can. I think you can do the DSE paper. It's roughly equal to DSE paper. The difficulty level is the same. Then we come to we have to hurry up. I don't want to talk too much. Actually, thermochem is the most simple topic in the DSE. To me, it's very simple. Number 24. Now you have 2 equations. Okay, one I label 1 and 2, and then you are given a choice. Which is correct? Oh, there's no hint. You have determined which is correct. Then you look at, you have SO2, SO3. You look at this one, SO3, SO2, SO2. Okay, so SO3 may be important. So we just we just look at this one. Heat of formation is a F. Okay, heat of formation. We write the heat of formation of SO3. Okay, because we look at the answer, it appear twice here. Delta of formation appear for B and D, so we have to you have appear 2. So normally we write the formation, the heat of formation here, the equation from the element at standard state. Okay, element for sulfur is solid state, and oxygen will be gas state. Then we balance it by multiplying the fraction. 3 divided by 2 times 2 will be the same. Okay, so this we write this way, and then we try to search the other equation. If you look at this one, if you want to eliminate SO2, you just add the first and the second equation together, but you divide the second equation by 2 or multiply by half. Why? Because you have the second equation have a coefficient to be 2 here. Okay, we want to get rid of the 2, so we divide by 2. We add together, then you give our heat of formation thermochemical equation, you get this one. So it's a big hint here. Then we add the two. We can add it together. Okay? And we can complete the cycle like this one. So you have sulfur, you search. So sulfur become SO2. So you just write it SO2. Then it's delta H1 here. For the same, at the same time, you have SO3 here. SO3 here is connected to SO2. So you have this one. Okay. Because you have 2 mole here, you have to divide by 2. You times half here. Then you get the result. Very simple. So you get the result. Okay, understand? So we have enough for this His law for inorganic reaction. Finally, we come to some organic reaction. Okay, some organic reaction. Number we look at number 26 first. Okay, before we go to organic reaction, number 26. I have something to tell you here. Here you have we want to ask about this reaction, so we write this out from left to right. Always when the question asks you about this one, you write the equation first, and then we want to make use of the first two to connect to make a cycle. Okay, then you have NO here, so you have NO. So look at this one, you have NO here. Okay, so it must go that way. So it becomes N2 and O2. So we write N2 and O2. Understand? We go this way. We have N2 and O2, and this have 2 moles of NO. Now here is only 1 mole. So we divide by 2. So we have this one. Alright. Then we find NO2 on the other side. Then we find NO2 here. Okay. NO2 here. Okay. Then we have N2 and O2 become NO2. We have this one. Will be 40. So we have 40 here. We connect by a cycle. Then we easily get the answer. Okay. The thing I want to tell you is this one. When we are balancing equation, sometimes we add some oxygen gas. Sometimes we get some hydrogen gas. Sometimes we add other elements as standard state. Remember that it does not affect delta H, because the enthalpy of element by definition is taken to be 0 as standard state. So you add something 0, it don't affect your value. You always add 0. So you just add oxygen or hydrogen element, whatever you want. Okay, whenever you want, you just add it whenever you want. Okay, this is what I want to tell you for number 26. Now, to end the tutorial, we have 5 more minutes. We want to look at some commonly examined organic reaction. So look at 29. The first point I want to remind you that you are always given the heat of combustion of carbon. Okay, we always use graphite. We never use a diamond. Okay, by definition, graphite, carbon in graphite state have an enthalpy 0 and the standard state. Okay, diamond is not the same. It's a bit higher. It's a few kilojoule higher per mole. And also, the combustion for heat of combustion for hydrogen is minus 2x6. So from 29, I want to look at the heat of formation here. Heat of formation for question number 30 for water. Heat of formation is also minus 2x6. Okay, I want to tell you that to burn 1 mole of hydrogen here to burn 1 mole, it gives 1 mole of water. So it's the same as formation of 1 mole of water here. Understand? And for graphite, to burn for combustion of complete combustion of 1 mole of graphite, 1 mole of C, is the same as, so look at this one, will be the same as here formation of 1 mole of CO2. Okay, the same, minus 394. In all kind of question, DSE, A level, and GCE, they all the question will give you 2 set of data. Here formation of one, and then here combustion of another, so that you, if you are not familiar with this point, you will get confused. Okay, so for graphite and hydrogen, their combustion enthalpy change will be related to the same as here formation of CO2 and water. Remember that. Okay, so we look at a few questions here. We look at number 29. It's very simple. Okay, very simple, very simple. Want to find the heat change formation of cyclopropane. I just don't care of what chemical it is. As long as you give me the formula, I can write it C3H6. It must be 3 carbon, 6H divided by 2, so 3 hydrogen gas, H2 gas. The state must be written clearly. If you don't have the state, you score no mark. You have a very strict penalty, because the state affects enthalpy. You don't have that state, the enthalpy is different. You must have the state. You will be deducted for marks for that. Okay, so we just write the question, the equation of the reaction asked in the question, formation of cyclopropane, and then we just connect it. So we are given here combustion, so we burn this into CO2, H2O, and we burn that way from the upper right hand side, C3H6 burn to CO2 and H2O. Then we connect it, then we get, very simple, we get positive 50. I'm sure you know how to do it. And then we go to 30. Okay, now we have the methanol acid. That's the acid produced by ant. 係啲蟻啊，係啲蟻produce 出嚟嗰啲 acid 啦 ，to defend himself against the snake, which is very smelly. Okay, now you burn this one. No. It's let me see. Change of formation. Sorry, formation. This is a formation. All right. So you have the formation here. You change from hydrogen gas, carbon, and O2 into 1 mole of methanol acid. It's also called formic acid or N acid. Okay, N acid. 2 words. Don't connect together. If you connect together, N acid become anti-acid. It is for curing indigestion. If you eat too much gastric juice in your stomach, don't mix it up. Don't write about N acid, otherwise you'll be misunderstood and have mark penalty. And now we want to have this reaction. We want to calculate the enthalpy change. So we write this one from left to right, and we connect this one, formation, and then we have another one, formation of CO2 and H2O. So it will be simple. Okay, going left to right. So you go from methanol down here. You're doing against the arrow, so you have negative and negative 409. Because if you do the reverse way, you get one more negative sign here. Okay, here. Understand? Then you do this way. You are on the right way, so you don't have to multiply. You don't have to multiply minus. You just add together. Simply, you get 13. All right. And remember, for a chemical reaction, you don't have to write per mole. You say that the enthalpy change is according to this equation. So this equation is 1 mole to give 1 mole and 1 mole. You don't have to mention it. It may be 2 mole or 3 mole. If you are given me 3 moles, I calculate it will be 3 mole. It won't be per mole. You don't have to get per mole. Okay. For most of the books, just don't think about that. They just add per mole to everything. It's meaningless. They don't understand it at all. And then 31, you have phosphorus acid, phosphorus 5 chloride, and it seems to be sophisticated, but don't be afraid. You are asked about this enthalpy change. It's hydrolysis. Don't bother about this one. Okay. Adding water and then it split, decompose. So hydrolysis, decomposed by adding water. Don't bother about that. So you ask about this one. So you write left to right, and then you want to find something about PCl5. You're given here formation, so you change phosphorus element, chlorine element to phosphorus 5 chloride. You just add the values here. Simple. And then also on the right hand side you have the phosphoric acid. So you have to do this one. Okay. So you have to go up there. You have hydrogen to give this one and also this one. You have chlorine to give Cl. You have oxygen. Okay, oxygen here, and you have P. Then you just do it. It is 5 times. So you have the value multiplied by 5 here. Okay, because you have 5 moles of HCl. Understand? Then you just go from left to right, the same as going down and up again by his law. Then you get the equation and you have minus 198 kilojoule per mole. Okay. Because it's a standard enthalpy change of PCl3. So the standard enthalpy change you have to add per mole. Okay. You have a definition of 1 mole of substance, so you have to per mole. Alright. Now the last one is simple one. You have the ether, dimethyl ether, methoxymethane. Then you want to calculate the combustion change. Then you write the combustion equation from left to right. You want to find this one. You go down and up. Okay. You search for 63063. You have this one. So by definition, formation is coming from element C, element H2, element oxygen. You go up here. Okay. So when you go another way, you have to add a minus here. You have to go another way. You have to add a minus sign. For going up is minus. Okay. Going up is minus. So here you have to add a minus here when you're going down. Okay. Then do the same for the right hand side. For the right hand side you have CO2, 2 mole, and 3 mole of water. So 2 moles of CO2, 3 moles of water. It's simple. Okay. So this ends part 2. So I think if you look at part 1 and part 2 all together, then you will be able to do all the do all the question in your DSE exam. So wish you for a fruitful examination result. And later in the summer holiday, because the COVID-19 just restrict me to go out for fishing and wandering in the world. So I have more time. I'll try to do some basic thing for CMI. 我會用中文做一紮嘅video 啦。Most important of all, I will explain a few years of DSE multiple choice in detail， 好仔細咁將大概首先我會做8年嘅 multiple choice 嘅解釋。Okay, so if you like my video, it's free of charge. You can what's that in English? 訂閱 so that when I have new video upload, you know, you can read it, you can watch it at the first moment, okay? And you can tell your friends to 訂閱啦 okay? I'll do some in Chinese and do some in EMI, both languages, okay? Maybe sometimes I'll do some Mandarin. I will talk in 普通话 so that my fellow Chinese in our homeland can also benefit from my teaching. Okay, I teach everybody. 正所謂有教無類嘛，有人教就唔會流眼淚啦。Okay, goodbye.